Given two cones of equal height, we'll show that they are proportional to their bases. The same is true for cylinders, which is evident because cylinders are 3 times the size of cones of the same bases and equal height. Let's prove this for the cones. We'll use a proof by contradiction and a strategy similar to what we've been doing. Assume the base L to the base n is proportional to the cone L to the solid O, where the solid O is less than the cone n. Inscribe a square in the circular base of cone n. As we've seen before, the square is greater than half the circle. Make a pyramid from the square of equal height to the cone. Then the pyramid is greater than half the cone. Now inscribe an octagon and make a pyramid out of the octagon. We can do the same with a 16gon and make better and better approximations to the cone. Eventually we'll have a pyramid whose difference from the cone is less than the difference between cone n and a solid O. For the sake of the argument, we'll say this happens at the octagon. So the pyramid n is greater than solid O, but less than cone n. Make an octagonal pyramid similar to pyramid n, but for cone L. The two octagons are proportional to the squares on their diameters, same for the circles, so the octagons are proportional to the circles. The cones are proportional to their circle bases, and the pyramids are proportional to their octagon bases. Therefore, cone L to solid O is proportional to pyramid L to pyramid n, or cone L to pyramid L is proportional to solid O to pyramid n. Cone L is greater than pyramid L, so solid O is greater than pyramid n. But we've already shown that pyramid n is greater than solid O, so there's our contradiction, which means base L to base n is not proportional to cone L to solid O, where the solid O was less than cone n. We can similarly show that base n to base L is not proportional to cone n to solid O, where solid O is less than cone L. Let's now assume that cone L to solid O is proportional to base L to base n, where solid O is greater than cone n. Then base n to base L is proportional to solid O to cone L, which is proportional to cone n to solid X, where solid X is less than cone L, for the same reasons as we've seen before. Then base n to base L is proportional to cone n to solid X, where solid X is less than cone L, which we just showed was impossible, so there's our contradiction, and base n to base L is proportional to cone n to cone L.